Good morning, students. Welcome to today's class, PowerPoint class on density. Once more, I am your tutor, Mr. Oyeredetunde Daniel. Remember, we already had this class in our Zoom class, so I would like you to pay attention to this YouTube class. And as much as possible, I would like you to go over the slide as many times as you can for proper understanding. Now, the objective of these lessons are to define density, state the formula for calculating density, mass, and volume, and their respective units, state the reason for the variation in density, state the procedure for determining the density of irregular and regular shapes, state the deduction that could be made from the density of gas, describe the concept of floating and sinking, describe the phenomenon of density and buoyancy. These are our objectives for this class. Now, when we say density, what exactly do you mean by density? The density of a substance is measure of the amount of matter that is present in certain volume of it. I repeat again, the density of a substance is a measure of the amount of matter that is present in a certain volume of it. Now, mathematically, the following equations are used in finding density. Density is equals to mass over volume, while volume is equals to mass over density. Mass, on the other hand, is equals to density times volume. And the unit of density is kilogram per meter cube or gram per centimeter cube. The unit of mass is either kilogram or gram, while the unit of volume is either meter cube or centimeter cube. Now, this slide shows us that density is defined as mass per unit volume. It is a measure of how tightly packed and how heavy the molecules are in an object. Now, how tightly packed and how heavy the molecules are in an object is referred to as density. Again, the density is the amount of matter within a certain volume. And as I said earlier, its unit is either gram per meter cube or gram per centimeter cube or kilogram per meter cube. Now, this diagram explains a density tower. Alcohol is made up of carbon and hydrogen, so it is pretty light, like oil. But it also has oxygen, but not much. You may think it to be a little more dense than oil, but alcohol molecules do not pack closely together. Because alcohol molecules are not closely packed together, they are less dense than oil. Oil is less dense than water. It is made from hydrogen and carbon. Carbon is lighter than oxygen, so it makes sense. Now, water is most dense. It's made from a hydrogen atom and oxygen, so it is denser. If you study this density tower, you will see that the lighter substance are always at the top, and the denser substance are always at the bottom. Alcohol is less dense than oil, and oil is less dense than water. It means water, out of the three, water is the most dense. Now, why is it that alcohol is less dense? Alcohol is made up of carbon and hydrogen, so it is pretty light like oil, but it also has oxygen, but not much. You may think it should be little more dense than oil. You may think it may be dense than oil, but alcohol molecules do not pack closely. Because alcohol molecules do not pack closely, it is less dense. Now, why do we have the variation in density? Remember, I discussed this in our previous class. Variation in density is as a result of two factors. Number one, atoms have different masses. Number two, atoms may be packed tightly or closely. These two factors are responsible for the variation in density. Atoms have different masses, and atoms may be packed tightly or loosely. Let me explain the first factor. The density of a matter depends on two things. First is the individual mass of each atom or molecule. Solid lead is denser than solid aluminium, mostly because a single atom of lead has 7.7 times more mass than a single aluminium atom. Again, the reason for density variation is because of atoms have different masses, and atom may be packed tightly or closely. Density depends on how tightly the atoms are packed. A diamond is made up of carbon and atom and has a density of 3,500 kilogram per meter cube. The carbon atom in diamond are closely packed. Paraffin wax is mostly carbon, but the density of paraffin is slightly only 870 kilogram per meter cube. The density of paraffin is low because the carbon atom are mixed with hydrogen atom in molecule than that takes up a lot of space. Remember, the two factors responsible for variation in density are that atoms have different masses. Atoms may be packed tightly or loosely. Measuring density of a rectangular solid. The mass of a block is found by placing the block on a balance. In order to measure the density of a rectangular solid block, the first thing you do is to measure the mass on a balance scale and takes the reading. The mass in gram or kilogram is recorded. The volume is found by multiplying the length, width, and height of the block together and record the value in centimeter cube. The density of the material in the block is found by dividing the mass by volume. Remember, density is mass over volume, and the answer you get could either be in gram per meter cube or kilogram per meter cube or gram per centimeter cube. Now, how do you find the volume of an object? To find the volume of an irregular object, you need water and a cup to help you measure. The volume will be the amount water rise in the cup when you add the object into it. In this slide, we have two measuring cylinders that are graduated. Now, the volume of the irregular object, that we want to look for. First, you take the initial volume of water in the measuring cylinder before you insert the irregular object into it. Secondly, you now drop the object into the second cylinder. When you drop the object into the second cylinder, obviously there will be increase in height. The difference between the final height and the initial height gives you the volume of the object. Density of an irregular shape, such as a pebble, can be found in the following ways. The mass of the pebble is found by placing it on a top pan balance. The volume is found by pouring water in a measuring cylinder until it's half full. The volume of the water is read on the scale, and the pebble is carefully lowered in the water on a thin string. When the pebble is completely immersed in water, the volume of the water is read on the scale. The volume of a pebble is found by subtracting the first reading from the second reading. The density of the pebble is found by dividing the mass of the pebble by the volume. I believe we discussed this extensively in our Zoom class. So I don't think you should have any issue with how to find the density of an irregular object. We also discussed the density of a liquid in our Zoom class, and the procedure is stated in this slide. First, a measuring cylinder is put on a balance and its mass is found and recorded as A. The liquid is poured into the measuring cylinder and its volume is measured and recorded as V. The mass of the measuring cylinder and the liquid it contains is measured and recorded as B. The mass of the liquid is found by subtracting A from B. The density of the liquid is then calculated by dividing the mass by the volume. Using this formula, density is equal to B minus A over V, while B minus A will give us the mass of the liquid. This slide slightly shows us how to find the volume of any object. First, you look at the mass of the graduated cylinder and water. Second, mass of the empty graduated cylinder. So the difference between the two gives you the mass of the water. To find the mass of the water, the procedure I stated above are the two methods of doing that. Now, not only water, any liquid that want to find the density, we can use the procedure that I mentioned above. Density of a gases, I've explained in details how the density of the gases can be found, but these are the basic deduction that can be made about the density of a gas. The density of a gas changes as its temperature and pressure change. As temperature and pressure change, the density of a gas also changes. The density of a gas are compared by measuring them at the same temperature and pressure. This is called STP. Remember, I told you that STP stands for standard temperature and pressure. When two gases meet, the denser gas rises above the less dense gas rises above the denser gas, as in the case of the density tower that I mentioned at the beginning of the class. So let me show you the density tower. This is a density tower. The lighter gases at the top, while the denser substance at the bottom. This is applicable to gases. We also discuss relative density. We say relative density is the ratio of density of substance to density of water. Water is used as a standard for comparison. To compare the relative density, water is often used as a standard. I said earlier that the unit of density is kilogram per meter cube or gram per centimeter cube, but relative density on its own has no unit. This table shows us the difference between density and relative density. The density of a substance is the mass of a unit volume of the substance. The relative density of a substance is the ratio of the density of the substance to the density of the water. And mathematically, density is mass over volume, while relative density is density of substance all over density of water. The SI unit of density is kilogram per meter cube, while relative density has no unit. Now, relationship between floating and sinking is explained in this slide. When a piece of wood is placed in water, the wood floats. This is due to difference in the density of the wood and water. When two substances such as solid and liquid or liquid and a liquid are put together, the less dense substance floats above the denser substance. This was explained in details in the previous slide. Why one object sinks and one object float. Now, buoyancy. What exactly do you mean by buoyancy? The upward force applied by a fluid on an object or the body when the object is put or submerged in water is called a buoyancy. And this explains why one object sinks and why objects float. Now, this diagram gives a clear explanation of what buoyant force is. Now, Archimedes' principle states that the upward buoyant force that is exerted on a body immersed in a fluid, whether fully or partially submerged, is equal to the weight of the fluid that the body displaces and acts in an upward direction in the center of the mass of the displaced fluid. Again, Archimedes' principle states that the upward buoyant force that is exerted on a body immersed in a fluid, whether fully or partially submerged, is equal to the weight of the fluid that the body displaces and acts in the upward direction to the center of the mass of the fluid displaced. Now, this is a demonstration of Archimedes' principle. This is the upthrust force, which is also the same thing as the buoyant force. And upthrust is equal to the weight of the displaced water. Now, the displaced water is shown in the small beaker. This question, I would like you to answer the following question, and in our Zoom class, we'll do a brief correction and necessary discussion on the question. Thank you and God bless you.